Welcome back to the GCSE Maths Pro YouTube channel. Today's video is more specifically for those AQA students who are doing higher tier, where we're going to be looking at the final question on your non-calculator exam that is often to do with trigonometric values. Now, obviously, if you're doing any kind of non-calculator exam, you will need to memorize certain trig values. So for sin, cos and tan, you need to know 0, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. So however you work out that you can memorize those, you'll need them. But more specifically, I've noticed a pattern for AQA students. As you can see, question 29, one of the ones towards the end, tends to be something like this. We don't even have any shapes. It's just literally using the values to work out some kind of maybe multiplication, division, anything like that. So let's tackle a few of these questions. Obviously, we're assuming that you already have them memorized. If you don't, just work it out on your calculator for now, but obviously make sure for the non-calculator exams that you do have the values memorized. Otherwise, you just won't be able to do these questions. I've also got the exam paper here in the top right corner if you want to actually reference that or look at the mark scheme yourself as well. So here we've got show that the value of 5 sin 30 times cos 30 times 8 tan 30 is actually an integer. So first of all, we're going to start by inputting the actual values for the sin, cos and tan. So first of all, we've got 5 sin 30, which means 5 multiplied by sin 30. So instead of sin 30, I'm going to write down 1/2 because that's the actual value, isn't it? The next one is just cos 30, which as a value is √3 over 2. And then we've got 8 times the value of tan 30, which is √3 over 3. Now that we've got this, that's our first step, then we just need to multiply everything. So we've got a bit of fractions and a bit of surds at this point. So 5 times 1/2, well 5 is a whole number, so you can write it as 5 over 1, which is then 5 times 1 at the top, and then 1 times 2 at the bottom. So 5 over 2 times by √3 over 2, let's just leave that there for now, and then we'll do the same over here. Again, put it as 8 over 1. The numerator is 8√3. With surds, we keep them separate to whole numbers, so that's why the 8 is still on the outside. Over, and then obviously 1 times 3 is just 3. So that's my first step. Then I can just go through and multiply all of these numerators together and all the denominators. So the numerators, again with surds and whole numbers, keep them separate. 5 times 8, when multiplying numbers, it doesn't actually matter which order you multiply them in. It's more important in this case to keep the whole numbers and the surds separate. So 5 times 8 is 40 on the outside. And then because we've got 2 surds here, those you can actually multiply together inside, so that would be √9. You might also be happy to know that obviously √3 and √3 cancel each other out. So instead that gives you 3 as a whole number. Either way, √9 or 3 as a whole number. Over 2 times 2, which is 4 times 3 is 12. Now let's just work out the numerator again. So 40 times 3 is obviously 120 over 12. And then we've got 120 divided by 12, which is obviously just 10. So you can see how we've got an integer as an answer. That just means a whole number. There's no fractions anymore. There are no surds. Everything's cancelled out. The answer is 10. So while this topic looks like trigonometry, really all it is the values to start with. Once you've got that, then you're actually moving on to fractions and surds. Okay, so you might have already got the hang of it by now. The next one we've got work out the value of cos 30 times sin 45 times tan 60, all of those in brackets squared. So again, first thing, I'm just going to input these values. We know that cos 30 is √3 over 2. Sin 45 is √2 over 2. And finally, tan 60 is just √3. All of that squared. So now we want to start multiplying. This √3 at the end that's not currently written as a fraction, I can write it as a fraction by putting over 1. You can do that with basically anything that's not already a fraction. Just put it over 1 so that we have the same format. Now multiplying fractions, I'm going to do obviously the brackets, what's inside the brackets first. Because if you think about BIDMAS or BODMAS, whichever of those you know, we do brackets first, then indices. So don't square anything yet, just do the brackets. So I'm going to multiply the numerators. They're all surds, so I can actually multiply those together. So either, again, you might look at it and go, well, I know that √3 and √3 will cancel each other out and become just a whole number 3, and then √2, or you might just want to multiply it all together and simplify it later. So you'll either get there root 18, that's fine, but you would then have to simplify that surd afterwards. Or as I said, you know that root 3 and the root 3 cancel out to become a whole number 3, and then we have a root 2 left. Then the denominator is 2 times 2 times 1 is obviously just 4. Okay, and then don't forget that that's then all squared. So we've dealt with what's inside the brackets, that's the most simplified I can get it. Now I'm going to square it. So when we square it, we just square the top and the bottom. So 3 squared is 9, root 2 squared is obviously either root 4, or that would then cancel to be just the whole number 2. And those are still multiplied together, over 4 squared, which is 16. So that then gives us 18 over 16, and then let's simplify that fraction, so we get 9 over 8. That's the most simplified. In this case, you can see it hasn't said an integer, because obviously the answer is not an integer, it's not a whole number. But we wanted to know the value, so we do want it as a number. In this case, it happens to be a fraction or a decimal. Okay, another question, 29. This time the formatting is in a fraction, but also we've got a subtract instead of just multiplying. And you can see they've actually asked us specifically to leave it in this particular format. So first of all, we want to simplify the fraction. So I'm going to start by inputting the values that I know. So we've got 2 times by sin 45, which I know sin 45 is root 2 over 2. Subtract tan 45, which is just 1, all over 4 times tan 60, which is just root 3. So actually there, I don't really need those brackets, do I? For root 3. Okay, so now I'm going to also simplify this fraction and the brackets here. 2 times root 2 over 2. Obviously, that just means the 2's cancel, don't they, those whole numbers? Also, the other reason is, again, if you think about it like this, 2 over 1 times root 2 over 2, you would end up with 2 root 2 over 2, and you can see the whole numbers would cancel. So in the numerator, I end up with just root 2 minus 1. I obviously can't subtract them because I don't know what root 2 is as an actual value in terms of the fact that it's a non-calculated paper, so just leave it separate like that. Over 4 root 3, that's the most simplified there. Now, we've simplified everything. However, if you look at the format of the answer, we've got 2 surds at the top, which we obviously initially don't have. And also, the more important thing is that the denominator is no longer a surd. You can see A, B, and C are integers, so C itself is just an integer, there's no surd there. So whenever you get questions with surds, and particularly when there's fractions, you normally at some point are going to have to rationalise the denominator. So in this case, we've just got a single term here, not plus or minus anything, it's just 4 root 3. We're going to multiply by, now you can either choose, you can multiply it by 4 root 3, just as the whole denominator, if that's easier to remember. Or I like to think of it as a bit more simple, just multiply by the surd. So however you prefer to remember how to rationalise, you either multiply by the whole denominator and just think of it like that so you don't have to worry about it, or just multiply by just the surd piece on its own, because that's the issue, isn't it? That's the bit we want to cancel out. So multiply the top and the bottom by the same thing, because that's just how fractions work generally, isn't it? So we've got effectively single brackets that we need to expand in the numerator. The denominator ends up being 4 root 9, which obviously root 3 times root 3 would cancel to become just a whole number 3. So that's 4 times 3. Okay, now let's keep working to get our simplified version. So I'm going to expand out the brackets. Root 3 times root 2, they're both surds, so I can actually multiply within the square root, so that's root 6. And then root 3 times minus 1 is just minus root 3, just itself, isn't it? Over 4 times 3 is 12. Okay, is there anything we can simplify there? In terms of the surds, no, we can't subtract them because they're not the same surd. It's a 6 and a 3, they're different. So we have to keep them separate. There's nothing we can simplify in terms of the surds themselves. They are the smallest version, aren't they? And then the 12 is the only whole number, so what else would I simplify that with? So there's our final answer. You see it's in the correct format. We've got root 6 minus root 3, so 2 surds at the top, and then a whole number at the bottom. So there's your final answer for that one. Just remember, you're likely going to have to rationalise if you ever have surds and fractions together. Okay, this is quite a similar question again, so if you feel like you've got the hang of it, then pause the video and give this one a go. The only thing that's different is the end part. So in terms of simplifying what we've got, that's fine. That's the same as kind of before, isn't it? But let's have a look. We actually have to show that all of this can be written as tan x, where x is an acute angle. So the actual ending point, the formatting at the end is slightly different. So don't worry about that for now. Let's just start off by seeing what we can do with the actual fraction. So for sin 30, we know sin 30 is a half, 4 times a half, minus tan 45, which we know from the previous one is 1, over 2 times cos 30, which is root 3 over 2. Okay, now let's just work through this fraction. What can we multiply and simplify? 4 times a half, again, if you want to think about it like this, is 4 over 1, but also think of it as 4 times a half is saying what is half of 4, which is obviously 2. So you end up with 2 minus 1 at the top. Over 2 times root 3 over 2, again, 2 over 1, or just think about it as times by 2 divided by 2, they're going to cancel out, aren't they? So that's just root 3 at the bottom. Then, obviously at the top we can subtract them, can't we? They're both whole numbers, so that's 1 over root 3. Now, this then depends how you've memorized the trig values. Some of you might have memorized them in the non-rationalized format, which is fine. In which case, just go, well, which angle, when we're using tan, gives me 1 over root 3? If you have memorized the trig values when they are already rationalized, hence there is no root 3 or any kind of surd in the denominators, then you would have to also rationalize this in order to recognize it. So that just depends how you've memorized the trig values. You might be able to go straight into it and go, yeah, I know that means tan of whatever is the same as 1 over root 3, or you might have to rationalize it and then figure it out. So I'm going to rationalize it just so we can complete the process. So let's bring it over here. We've got 1 over root 3. As we said before, we want to cancel out the surd denominator, so you multiply top and the bottom by that surd. So the top is obviously 1 times root 3, which is just root 3. And the bottom would be either root 9, which would then square root, or you can just see it as those would cancel to become a whole number 3. That's the rationalized version. This is the version that I've been using in the previous questions. You might be using the unrationalized version, which is absolutely fine, as long as if they have asked you or shown that you need to rationalize it at the end, that you do so. So either you're looking at 1 over root 3, which value of tan is that, or you're looking at root 3 over 3. Obviously the answer should be the same. Tan of what angle is root 3 over 3? They've also said x is an acute angle. That just means it's less than 90. So it's obviously one of those ones in that table of values that you've memorized. It's basically just the backwards process, isn't it? We've gone from knowing, for example, tan 45 is 1. It's then saying, well, what is 1 in terms of tan? It's 45 degrees, isn't it? In this case, it's 30, isn't it? Tan 30 is the same as either of those two values. So it says can be written as tan x. So your answer, just to be clear, the format of your answer is tan 30. Not just 30, because they've said it can be written as tan something. So we need to include tan. So yeah, just make sure you double check the question. Have they asked me just to kind of simplify it, or have they asked me to convert it back into one of the trig ratios? Okay, again, this is kind of a similar question. We've got 3 marks now instead of 4 though. So question 27, angle x is acute, again, somewhere between 0 and 90. They've said that cos of that angle is the same thing as sin 60 times tan 30. Work out the size of angle x. So for this one, they're asking for x, not cos x. So for this one, they're just asking us to write down what x should be at the end. But again, don't worry about that for now. Let's just focus on this side of it. Let's put in those trig values and then multiply them. So we know that sin 60 is the same as root 3 over 2. Multiply that by tan 30, which we should know is root 3 over 3. And now let's actually do the multiplication. So multiplying the numerators, either, again, those two cancel out to become just 3 as a whole number, or you can write it as root 9 and then square root. Completely up to you. I'm just going to go straight to 3. Over 2 times 3, which is 6. Now, what does that simplify to as a fraction? 3 over 6 is obviously a half. Okay, so let's look at it over here. They're saying that cos x equals a half. And now we're kind of working backwards again, same in the last question. What angle, when it's put with cos, gives us a value of a half? So it's kind of just working backwards in our mind. Well, hopefully, if you've memorized them by now, or at least if you're looking at the table in front of you, you can figure out that x is 60 degrees. And obviously that is acute, it's less than 90. So in this case, our answer wasn't cos 60, it was just what is x? Okay, 60 degrees is the answer. Okay, final question now. Hopefully by this point we've got the hang of it slightly. So we've got 4 times sin 30 times tan 30 times cos 30 can also be written as or is equal to sin y. Work out one possible value of y. This one they haven't mentioned the fact that y is an acute angle. Hence why they're saying one possible value. Because there could be multiple. There's actually multiple options. If you think about the sin graph, it's a wave that carries on and carries on and carries on, doesn't it? So there are multiple options, but they just want one of those. So let's do the same thing as we did before. Even if you're not sure what they mean by one possible value of y, don't worry about that. Just focus on this bit that we can actually figure out and simplify. So we've got 4, which we're still putting there. Sin 30 we know is a half. Tan 30 we know is root 3 over 3. And then cos 30 we know is root 3 over 2. Okay, let's multiply all of that. Again, you could think of it as 4 over 1 if you like. 4 times 1 is the whole numbers, so that's 4, and then root 3 times root 3, again, either root 9 or just put it straight as 3, so those are multiplied, 4 times 3. 1 times 2 is obviously 2, times 3 is 6, times 2 again is 12. Then we've ended up here with 12 over 12, which obviously gives us 1. 12 divided by, how many times does 12 go into 12? Obviously once. So this is the bit that we're saying is equal to sin of the angle y. Now, this is the exact same process. If you think about it from your table, which angle gives you a value of 1 when you put it with sin? You might also imagine the graph. You know that sin, hopefully you know that the sin goes like that. 1 minus 1. So we're saying there's 1, isn't it? What is this value on the x-axis? Hopefully you know that is 90 degrees. The reason why they said one value, if I come back to that, is that, as we said, this wave carries on. So technically, terrible drawing here, but technically, that's at 1. This one over here is also at 1. That's technically 450. Now, obviously, before when they said that it has to be an acute angle, if you wrote down this, 450, you'd get it wrong. In this case, they haven't mentioned it has to be acute. So you could write 450. You could write whatever this one is here. You could write, it obviously goes back negative, doesn't it? There's a 1 over here. You could write that one. Obviously, the most obvious answer, the probably easiest answer, is going to be the 90, isn't it? Because that's the one you know from your table of values. So that's probably the one I would stick with. But just so you can understand why they've said work out one possible value, because there could be multiple depending on where you look at the graph. Okay, so they've said work out one possible value y, so we want to know y. I'm going to go with 90. I think that's the easiest answer, isn't it? These previous ones, if we quickly go back, only had one answer. They said work out the size of angle x as if it's just one answer because of the fact that they mentioned that x is acute. So here, even though obviously the cos graph starts at 1, doesn't it? It does the same kind of wave. This is a half, so a half is about here. This is the answer that we put down, wasn't it? 60. But do you see how there would be this minus 60? And there would also be this one here, which is about 300. However, that's not an acute angle, is it? 300. So that's why 60 was the only answer they were looking for. It was an answer between 0 and 90, which is the only one there is 60. Okay? So that's the reason why we only had one answer for this one and the previous one as well. Because of the fact that they'd mentioned that it's an acute angle. It's between 0 and 90. So they've kind of narrowed down that part of the graph that we could have looked at. And therefore there was only one actual answer. For the last one, they didn't mention it being an acute angle. They didn't give us any range or any limits. So it could have been any of these values to infinity, basically, that crossed at 1. Obviously, again, as I said before, you're probably going to go with 90. So you don't need to worry about that, but it's just a bit of an explanation just in case you were interested as to why this question was worded slightly differently. So that is everything on trig values. Obviously, make sure that you memorize them before the non-calculator paper, but I've seen this question for AQA particularly. It seems to come up pretty much every year. So thanks for watching this video. If you had any questions or comments, please leave them down below, but make sure to like and subscribe and check out any of my other videos if you find them helpful.